So our song today is You're the Inspiration by Chicago. And our topic is lines of fit. So instead of writing our own equation for a line of fit, we're going to learn how to use a graphing calculator to write the equation for the line of best fit. And we're going to use that equation to make predictions and analyze. All right, lots of vocab today. Make sure you get these down. These are probably not vocab terms that you have memorized just yet. Regression is the statistical study of the relationship between variables. So when we talk about using a graphing calculator to write the equation for the line of best fit, it's called a regression line. Correlation is the strength and direction of the linear relationship between two variables. Notice that it says linear. So when we use our graphing calculator in a minute, we're going to be given a correlation coefficient, which only applies if the correlation is in a linear relationship. So we wouldn't get a correlation coefficient if it followed a different kind of pattern. Positive correlation is when both variables increase together. So for example, your shoe size and your height. As you age, both your shoe size and your height increase up to a certain point. Negative, one variable increases as the other decreases. Now be careful with this one because a lot of people tend to think that if both variables decrease, it's a negative correlation, which is not true. That would be a positive correlation. So think back to that lesson we did when we had a negative over a negative for our slope, and it's simplified to a positive, same concept. So an example of a negative correlation would be outside temperature and your heating bill. As the outside temperature increases, your heating bill decreases, so they would have a negative correlation. And then if there's no correlation, obviously no relationship. So as I mentioned, we're going to be finding the correlation coefficient. And this is a number between -1 and 1. Lots of information about the correlation coefficient. The number describes how well the data fits the line and whether the correlation is positive or negative. So if the correlation coefficient is -1, that does not mean it's a bad fit. It's actually a perfect fit for a negative correlation. And then if it's +1, it's a perfect fit for a positive correlation. 0 means that there's no correlation. So the closer the correlation coefficient is to 0, the less linear relationship we can gather from the data. The graphs at the bottom of the page here are also in your book on page 143, so don't feel like you have to copy these down. You may just want to note where they are. But this gives you an idea of the different types of correlation. So the R is standing for the correlation coefficient. So in our first graph here, we have an R value of -0.95, which is pretty close to -1. So it's a pretty strong relationship, and you can tell that when you're looking at the graph. The data are almost linear. The next one, you can kind of see that they're sort of related in a negative way, and that is reflected in the R value. It's almost halfway between 0 and -1. So it's a very weak correlation, but there is some sort of relationship there. And then we see the correlation of 0. Of course, the scatter plot is all over the place. And then we'll see the positive 0.6 and the positive 0.95 as well. Okay, so we've got a long example here. I'm probably going to be pausing in the middle of this example to kind of break up our videos. But what we have is we have a data set of minimum temperatures in Albany, New York versus Sydney, Australia. And what I would like you to do is make a scatter plot. And I've already done that just to save some time on the video. So here's what my scatter plot looks like. Let me scroll this back up again. Go ahead and pause the video with the data there so that you can get your scatter plot created. All right, so your scatter plot should look similar to mine. Maybe it's slightly different depending on how you scaled your axis. But you should notice a fairly strong negative correlation. The scatter plots almost line up perfectly on a line. And so we're going to see what exactly that correlation is in a minute. So I would say it is a fairly strong negative correlation. Okay, So now we're going to use a graphing calculator. I'm going to pause the video here since we're at the 5-minute mark.